So see, good afternoon to one and all. So in the previous lecture, previous practical lecture, so we have conducted some practical on Tinkercad. That is, we have conducted the practical related to Thevenin's theorem, that is verification of Thevenin's theorem, verification of Norton's theorem. Also, we have conducted the practical, that is verification of KCL or mesh analysis technique and verification of node analysis technique. So this core practical we have already conducted in the previous practical lecture. Now, today we will discuss about the next one practical or experiment number 5 is that verification of superposition theorem. Okay, so verification of superposition theorem. Now, you know that what is the statement of superposition theorem. So superposition theorem, it will states that statement of superposition theorem, that is this theorem, it will be states that in a linear bilateral electrical network, if it is containing more than one energy sources, then the current through any branch, it is equal to the sum of the current through that branch due to individual source acting independently or individual source acting alone. Okay, so that means if any circuit, it will contain more than one independent sources. That means suppose there are two voltage sources, or it may be there are one current source, one voltage source. That means more than one independent sources. Then if we want to find the current flowing from any one of the branch, so this current in any one of the branch, it is equals to the sum of current that would be produced when individual source acting alone. So this already I have given a statement in the theory also, and we solved some problem related to that. Okay, we solve the problem related to that. So our theorem is that to verify, practical is that aim to verify the superposition theorem by using an simulation, or it may be by using any one of the software. It is verified either theoretically and practically. Theoretically पण verify करायचे, practically पण verify करायचे. Okay, so see, to verify the superposition theorem, its statement is that here it is statement is given. Hello. Okay, now here it is statement. This theorem, it can be stated that any linear two-terminal network, it will containing more than one independent sources, then the current flowing from any one of the branch, it is equal to the algebraic sum of current that would be produced when individual source acting alone, or it may be individual source acting independently. प्रत्येक सिच्युएशनला एक सोर्स ऍक्ट करून जो करंट येईल त्या आलेल्या करंटची जी काही सम असेल, सो दिस सम इट इज नथिंग बट this sum, it is equal when each and every individual source acting alone. Okay, so see, this is the statement. We will see first of all network. See here in this circuit diagram, there are two voltage sources. That means there are two independent sources, V1 and V2. These are the two independent sources. Suppose in our observation table, we have calculated the current for each and every element. That is, we have calculated current for R1, current for R2, and current flowing through the R3 also. Okay, so that in the observation table, I have given a 3 reading, that is current through resistance R1, current through resistor R2, and current through resistor R3. So see, you also calculate any one of the branch current also. कुठल्या एका ब्रांच मधला करंट आपण कॅल्क्युलेट करू शकतो. See, there are two independent voltage sources, V1 and V2, then current, suppose I want to find out the current flowing from this R2 resistor. Okay, suppose I want to find out the current flowing from this R2 resistor. So this will be calculated when by applying superposition theorem, when first one source is acting alone, पहिला ज्यावेळेस सोर्स ऍक्ट करतोय त्यावेळेस करंट काय येईल, तो करंट at that situation other source, if there are voltage source, it can be short circuited. If there are current source, it can be open circuited. Okay, so see, this source is short circuited when this V1 is acting alone, and then second step is that when this V2 is acting alone, at that situation this source, it can be short circuited. हा source काय करायचा, short circuit करायचा. Then we will calculate the current flowing from this. याच्यामधून फ्लो होणारा करंट कॅल्क्युलेट करायचा. That is suppose current flowing from this is nothing but Ix. याच्यामधून फ्लो होणारा करंट Ix आहे असं कन्सिडर केलं. So first of all we will do the theoretical calculation. First of all we will select the value of resistor, then voltage. So see, we have taken the observation. We have taken the observation is that suppose voltage V1 is equals to 20 volt, V2 is equals to 24, R1 is equals to 12, R2 is equals to 2, and R3 is equals to 4. Suppose we want to find out the current flowing from 2 ohm resistor. 2 ohm resistor madun flow honara current calculate करायचं. Okay. So see, we will calculate the current. Here it is. We have selected the voltage. V1 is equals to 20 volt. V2 is equals to 24 volt. Then this R1 resistance is nothing but 12 ohm. R2 resistor, it is nothing but 2 ohm. And then R3 is nothing but 4 ohm. So these are the value are given. And we want to find out the current flowing from this. That is, suppose I have represented the current flowing from this is nothing but Ix. Okay. See, theoretical calculation we will do first. So first step is that in case of superposition theorem, first one step is that when 20 volt voltage source, 20 volt voltage source is acting independently or acting alone. ज्यावेळेस 20 वोल्टचा व्होल्टेज सोर्स आपण काय करतोय, ऍक्ट करतोय at that situation. See, when the 20 volt voltage source is acting alone, at that situation this is become short circuited. This is shown in this figure. या फिगर मध्ये दाखवलेलं आहे बघा. So here 20 volt voltage source, here it is resistance 12 ohm, here it is 4 ohm, and here it is 2 ohm. We want to calculate the current flowing from this 2 ohm. याच्यामधून फ्लो होणारा करंट कॅल्क्युलेट करायचा आहे. At that situation this voltage source becomes short circuit. See, represent the current flowing from this is nothing but I1, then current flowing from this is nothing but I2. So what is Ix? I have represented here Ix. First of all, from figure tell what is meant by Ix. Ix is equals to Ix is equals to I1 minus I2. Okay, now apply KVL to the mesh 1. Mesh 1 la KVL apply kela, so it becomes plus 20 minus 12 I1. Then I will write in the table. So see, plus 20 minus 12 I1 minus 12 I1 minus 2 in bracket I1 minus I2. I1 minus I2, then it is equals to 0. Simplify this, that is 20 minus 12 I1, 20 minus 12 I1 minus 2 I1 plus 2 I1 plus 2 I1, it is equals to 0. Now shift this minus term. Here it is I2, sorry, here it is I2. Okay, now shift this I1 and I2 term to the right hand side. So it becomes 14 I1. It becomes 14 I1, 14 I1 minus 2 I2. It is equals to 20. So this is equation 1. This is one of the equation. Then apply KVL to the mesh second. Mesh second la KVL apply kela. So what is the value of R3? R3 value of R3 is nothing but 4. So 4 I2 minus 2 into I2 minus I1. I2 minus I1, it is equals to 0. So see, simplify this. That is 4 I2 minus 2 I2 minus into minus plus, it becomes plus 4 I2 minus 4 I2 minus 4 I2 na, sorry, here it is minus 4 I2, here it is minus 4 I2 minus 2 I2 plus 2 I1 plus 2 I1, it is equals to 0. So simplify this, that is minus 4 minus 2 is nothing but minus 6, that is 2 I1 minus 6 I2, 2 I1 minus 6 I2, it is equals to 0. Okay, So this is equation second. Tell me from equation 1 and 2 what is the value of I1 and I2. Value of I1 and I2 किती येते? कॅल्सी आहेत का? Value of I1 and I2.
I1 0.5.
I1 0.5. I2
I1 1.5 and I2 0.5.
I1 1.5 and I2 0.5.
0.5.
0.5. Okay. I1 1.5, I2 0.5. So according to the, first of all, calculate the Ix. Value of Ix. Ix ची value काय formula Ix साठीचा? Ix is equals to I1 minus I2. Ix, it is equals to, we have already determined from figure, Ix is equals to I1 minus I2. So value of I1 is nothing but 1.5 minus value of I2 is nothing but 0.5. So it is equals to 1 ampere. Okay. Ix ची value मिळाली when V1 source it is acting alone. V1 voltage source, it will be act alone. At that situation, we have calculated the value of V1. V1 ची value calculate केली when the 20 volt voltage source is acting alone. Okay. Now second voltage source, that is we have selected this voltage source is 24 volt. 24 volt voltage source is selected. So at that situation, we want to calculate the value of Ix. Again, we want to calculate the value of Ix. So first situation, it can be represented as Ix dash. Second situation, it can be represented as Ix double dash. So Ix double dash ने represent करायचे. See, V2 is equals to 24 volt, R1 is equals to 12, R3 is equals to 3, R2 is equals to 2. Again, we want to find out Ix double dash. Okay, so Ix double dash find करायचे. Again, represent the current flowing from this is nothing but I1. Current flowing from this is nothing but I2. When 24 volt voltage source is acting alone. See, apply KVL. KVL apply kara first one mesh la. So when apply KVL to the first one mesh, that is minus 12 I1 minus 12 I1 minus 2 I1 minus I2. I1 minus, that is minus 2 I1 minus I2. Okay, I1 minus I2, it is equals to 0. So simplify this, that is minus 12 minus 2, it becomes minus 14 I1, then plus 2 I2, it is equals to 0. It is equals to 0. This is first one equation. Second one equation is that, write down the second one equation. When apply KVL to the mesh second mesh la KVL apply kela. So while applying KVL to the mesh second, see, mesh second equation, that is minus 3 I2, then plus minus, it becomes minus 24, then minus 2 I2 minus I1, okay. So I2 minus I1, it is equals to 0. Now simplify this, that is minus 3 I2 minus 24 minus 2 I2 minus into minus plus 2 I1, it is equals to 0. Again rearrange this equation, just 2 I1 minus 3 minus 2 is nothing but minus 5 I2. So rearrange equation, 2 I1 then minus 5 I2, 2 I1 minus 5 I2. So minus 24, it can be shifted to the right hand side, it is equals to 24. So this is equation second. By solving equation 1 and 2, what is the value of I1 and I2? I1 and I2 ची value सांगा. I1 is equals to and I2 it is equals to. Put the value in calculator and tell me the answer. पुट करा व्हॅल्यू. हिअर इट इज -14. इथली व्हॅल्यू नाही का तुमच्याकडं? सो इट बिकम्स -12 and -2 I1 is nothing but -14 I1 plus 2 I2 plus 2 I2. It is equals to plus 2 I2. It is equals to 0. So here equation 1 आहे. This is equation 1. This is equation 2. From equation 1 and 2, what is the value of I1 and I2?
सर R3 ची व्हॅल्यू 3 का 4 आहे?
4 आहे ना? Sorry. Value of R3 it is nothing but 4. Here it is 3. Here it is 3 given, no? So it becomes, here it is 4. So here it is also 4. It becomes, here it is 6. बरोबर ना? Right. So these two equation. 2 I1 minus 6 I2 is equals to 24 and minus 14 I1 plus 2 I2 it is equals to 0. या दोन इक्वेशन किती येते व्हॅल्यू? What is the answer? I1 is equals to
-0.6.
I1 is equals to
-0.6.
minus 0.6. Then
I2 -4.2.
I2 is equals to minus 4.2, no? I2 is equals to minus 4.2 ampere. Okay, see what is the Ix? Ix ची व्हॅल्यू काय येईल? Ix double dash is equals to Ix double dash it is equals to, okay, see Ix double dash ची व्हॅल्यू. सो इथला करंट फाइंड करायचा आहे. डाउनवर्ड फ्लोइंग करंट I1, अपवर्ड फ्लोइंग करंट I2. सो I1 minus I2. I1 ची व्हॅल्यू minus 0.6 minus of minus 4.2 किती येईल व्हॅल्यू?
3.6.
3.6. Okay, so answer for this is nothing but 3.6. So see, total current flowing from this is nothing but total current flowing from this 2 ohm resistor, that is I is equals to Ix dash plus Ix double dash. Ix dash plus Ix double dash. So Ix dash ची value 1 plus Ix double dash ची value 3.6 ampere. So it becomes 4.6 ampere. Okay, so 4.6 ampere. So this we want to verify by using simulation, or it may be by using simulation value. So see, we now see the Tinkercad simulation. Okay, I will clear this all drawing or return value. Now see, we required two voltage source. We required two voltage source. That is one of the voltage source. It is nothing but value of this voltage source. It is nothing but किती value है? 20 volt. Suppose I have represent current here. It is nothing but 5 ampere. Then second voltage source we required here. It is 24 volt. 24 volt voltage is required. I have represented here 5 ampere also. See, value of resistor. Resistor ची value, first one resistor, it is nothing but 12 ohm. R1 value of 12 ohm. Then value of R2. We will do connection once again. So choose the value. This voltage source 20 volt. This voltage source 24 volt. Now I required one multimeter to measure the value in each case. प्रत्येक केस मध्ये मला व्हॅल्यू मेजर करायचे. एक मल्टीमीटर पाहिजे. Then select the value of resistor. Resistor first one 12 ohm. Then resistor second one. Second one value of this resistor is nothing but 4 ohm. Then third one resistor is nothing but the value of this resistor. It is nothing but 2 ohm. Okay. Now see, do the connection as per our circuit diagram. Circuit diagram प्रमाणे connection करून घ्यायचं. See, this resistor, that is I will represent here. Okay, see, voltage source positive terminal, it is connected here. Voltage source negative terminal, it is connected here. Now see, the positive terminal of first one voltage source, it is connected to resistor R1 first terminal. पहिल्या टर्मिनलला कनेक्ट केलेलं आहे. सर्किट डायग्राम बघा. So here it is, first one terminal ला कनेक्ट केलेलं आहे. Now next terminal of R1, it is connected to R3 and R2 terminal. That means it is one of the common terminal. You just I just connect here one of the ammeter, that is to measure the current flowing from this. याच्यामधून फ्लो होणारा करंट मेजर करण्यासाठी मी एक ammeter कनेक्ट करतोय. Okay, so see, I will connect this positive terminal of this, it is nothing but here, and negative terminal of this, it is nothing but here. So hence I measure the current. Now this terminal, it is connected to this resistor, next one resistor, that is R3 resistor. Now see, first one situation is that, first one situation is nothing but we want to find out, or पहिल्यांदा आपण total current find करून घेऊया, and then we will find out the current through each voltage source when each voltage source is acting alone. So see, again I will connect this voltage source. Here it is positive terminal, then here it is negative terminal. Okay, now this positive, it can be connected to this resistor, and this negative terminal, it is connected to common negative terminal. Again this terminal, it is connected to here. Okay, so this is the connection diagram. So I will start the simulation. See, what is the current? Total current flowing, total current when both voltage source is acting, दोन्ही voltage source ज्यावेळेस ऍक्ट होत आहे त्यावेळेचा करंट is nothing but 4.60 ampere. आन्सर किती आलंय आपलं? किती आलं होतं?
4.6.
4.6 आलं होतं. ओके, सो इट इज करेक्ट. नाउ I will use the procedure. आपली प्रोसिजर आता यूज करूया आपण. That means when first one source is acting alone, पहिला सोर्स ज्यावेळेस ऍक्ट होतोय, at that situation second source is short circuited. When it is short circuited is nothing but the voltage across this is nothing but how many, याच्यामधून याचं voltage किती असेल?
0.
0. So I have select the voltage of this second voltage source, it is 0. Okay, so I have selected the second voltage source is 0. That means it is short circuited. The short circuit झालं. So इथे मी 0 select केलं. Then I will do start simulation. What is the value of current? Current flowing from 2 ohm resistor. What is the value? 1000 milliampere. So our answer, आपला आन्सर काय होतं? 1000 milliampere is nothing but 1 ampere.
1 ampere.
1 ampere. So our theoretical answer is also similar, that is 1 ampere. Okay. Now second situation is that when second one source is acting alone, at that situation first one is short circuited. First one short circuit करतो मी, so it is put as a 0. Voltage across this, it is put as 0. Now I will start simulation. What is the answer?
3.6 ampere.
So 3.6 ampere. So total current flowing from this is nothing but 4.6. So addition of this current when each source acting alone. प्रत्येक source alone ज्यावेळेस act होईल, जी काय addition येईल. So this is nothing but total current flowing from this 2 ohm resistor. Or it may be we can calculate similarly for 1 ohm resistor also. जर आणखी मी मल्टीमीटर यूज केले आणि याच्यामधला करंट व्हेरीफाय केला तरी पण तो सेम येईल. Again, if I use again one of the multimeter to measure the current flowing from this third one, so again this current is also same. Okay, getting? Hence this superposition theorem, it can be verified. Hence the superposition theorem, it can be verified. Okay, लक्षात आलं का? Is there any doubt? Hello. Similarly, we also calculate the current flowing from each and every. प्रत्येक मधून फ्लो होणारा करंट, but calculation, that is theoretical calculation is more. Suppose we want to calculate the current flowing from R1 register. R1 register मधला जर करंट तुम्हाला कॅल्क्युलेट करायचं असेल तर अगोदर theoretical calculation करावं लागेल. Here इथं काय ते डायरेक्ट दाखवेल. So see, I will show you also. I will take another one multimeter. That is, this one is one of the multimeter. I want to measure the current flowing from this resistor R1. R1 मधला current find करायचं मला. So I will connect this multimeter from this positive terminal. It is connected to positive terminal of the multimeter. Negative terminal of the multimeter, it is connected to resistor. Suppose I want to measure the current flowing from R1 also. When individual source acting alone, each and every source ज्यावेळेस act होतोय त्यावेळेस मी calculate करतो. See, suppose the voltage is nothing but 20. Then voltage is 24. So I will start simulation. So see, set it as an ampere. Okay, see, it is nothing but 900 milliampere. Okay, current flowing from R1, it is nothing but 900 milliampere. Okay, when each source acting alone, so suppose I act first one source, that is second one is short circuited, I will put it is 0, then start simulation. So it is nothing but 1.50 ampere. Okay, 1.50 ampere. First one situation chala. Then second one situation is that, stop simulation. I will put here 24, 0. So it is nothing but minus 600 milliampere. So see, अगोदर आलेली व्हॅल्यू 1.5 ampere, 1.5 minus 600 milliampere. Okay, 600 milliampere is nothing but 0.6. So the value becomes 0.9 ampere or 900 milliampere. So again, it is also verified. Okay, getting? लक्षात आलं का? Hello.
Yes, sir.
Okay. Now we will see the next one practical is that verification of maximum power transfer theorem. That is maximum power transfer. It is similar to that of Thevenin's theorem. Just represent the RS, that is load current, load resistance RL. It is equals to RTH. म्हणजे जी RTH ची value येईल ती value it can be represented as a load current, and then we will find out by using formula, that is Pmax. Pmax can be calculated by using a formula, that is VTH square divided by 4 into RTH or 4 into RL. Okay, so see, verification of maximum power transfer theorem. In maximum power transfer theorem, again it is similar to that of VTH. So here it is RL, it is, so that I have not given RL, so I have given observation. See, voltage V1 is 50, resistance R1 is equals to 10, R2 is equals to 15, R3 is equals to 5. I have not given the value of RL because the value of RTH, it is equals to RL in case of maximum power transfer theorem. Maximum power transfer theorem मध्ये value of RTH, it is equals to RL असते. Then and then only, so this is condition, then and then only we can transfer maximum power from source to load, or maybe one end to other end. Okay, so जी RTH ची value येईल तीच RL ची value represent करा. RL is equals to RTH, it is equals to the value that is we determine the value of RTH. Okay, so see, similarly VS is taken 50. First of all, remove the load resistance RL. पहिल्यांदा RL remove करा. Then calculate the voltage, open circuit voltage VTH across that. VTH calculate केलं. Then after calculation of VTH, just short circuit the voltage source and calculate the RTH by series parallel reduction technique. By series parallel reduction technique, calculate the RTH. Then finally draw the Thevenin's equivalent network. Okay, so Thevenin's equivalent network. Then calculate the value of IL, or just calculate the Pmax is equals to VTH square divided by 4 into RTH. Okay, VTH square divided by 4 into RTH त्याच्यावरून Pmax calculate करून घ्या. So this is the theoretical calculation. So simulation we can see only the value of VTH and RTH. RTH ची आणि VTH चीच value फक्त बघणार. And load current IL is also we have calculated in VTH. So just write this and calculate the Pmax. In the conclusion, write the maximum power, that is Pmax. Conclusion मध्ये maximum power लिहा. Hence we verify the maximum power transfer theorem and value of Pmax it is equals to dash dash. जे काय आले असेल ते लिहा. Okay. So see, again we will do the circuit simulation. We have already done the Thevenin's theorem practical. So that again I will do here also. I will remove all the connection. Okay, see, set the value of resistor. First of all, set the value of resistor. Resistor ची value set करून घ्या. Voltage source, voltage we have applied here 50 volt. Then 50 volt and select the current is also 15 ampere. Now resistor, first one resistor, it is nothing but 10 ohm. Then resistance R2, where it is R2? R2 is here, R3 is here. What is the value of R2 and R3? R2 15, R3 5. So R2 it is nothing but 15. Here it is 15 ohm. R3 it is equals to 5 ohm. Okay. Now see, I want to calculate the VTH. So VTH is nothing but open circuited voltage across these two terminal. So resistance terminal and here terminal. So suppose I have extended this terminal here. Just connect the VTH for calculating VTH. Positive terminal is here, negative terminal is here, and voltage it can be applied as a 50 volt. So do the connection. It can be connected to positive terminal. Then this is a common terminal. It is connected to negative terminal. Okay, so this is the simple connection. I want to calculate the VTH. So just select voltage, start simulation. So VTH, value of VTH, it is nothing but 30 volt. Okay, so that value we have already calculated in the verification of Thevenin's theorem also. Okay, so it is 30 volt. Suppose I want to measure the resistance RTH across this terminal A and B. A and B च्या terminal च्या across मला resistance measure करायचा आहे. Just put the first one voltage source short circuited. So voltage source short circuited is nothing but voltage across this terminal is 0. So I have selected this. Again, I have start simulation and measure the resistor. Select this voltmeter as a resistor. So it is nothing but 11 ohm. Okay. So resistance is 11 ohm. And for maximum power transfer, write the sentence. For maximum power transfer theorem, RL is equals to RTH. So again, RL is equals to 11. RL पण काय येईल तुमची? So see here, the value of RL is equals to 11 ohm. Value of RTH is equals to 11 ohm. Okay. So see, then the value of current I1. I1 it can be shown in the first one. इथं I1 दाखवला होता बघा. So when I have selected here 50 volt and measure the voltage, start simulation. I1 is equals to 2 ampere. So you just write in the observation table, I1 is equals to 2 ampere, VTH is equals to 30 volt, then RTH is equals to 11 ohm, and then IL. So IL we want to calculate. IL calculate करायचं. IL कसा calculate करतो आपण? So for drawing an equivalent circuit. So equivalent circuit draw करून आपण IL calculate करतो. So I will draw the equivalent circuit. See in the this I will draw one of the equivalent circuit, that is see for drawing an equivalent circuit I require 2 resistor only. I want 2 resistor which are connected in series and total voltage VTH. So VTH I have selected. I will select the VTH. VTH किती आहे? 30. So VTH is equals to 30. I will connect one voltmeter multimeter in series with that to measure the current. For measuring of current, I will connect one of the voltmeter. Okay. So see 30 volt. Set the value of RTH. RTH is equals to 11 ohm. Again, value of RL is equals to RTH. So value of RL is also 11 ohm. So I want to measure the current. So see the current. It is, sorry, here it is selected as a ampere. Okay. See current flowing from this loop. It is nothing but 1.36. Then calculate the value of VTH according to the formula, that is VTH. It is equals to calculate the value of P max, that is maximum power. P max, it is equals to VTH square divided by 4 into RTH or RL. So see VTH square is nothing but 30 square, 30 is a square, divided by 4 into RL. 4 into RL, value of RL is nothing but 11. किती येते calculation है? Hmm.
20.45. 20.45.
20.45. VTH square divided by 4 into 11. So it becomes, so this is the maximum power. So this can be done by theoretical. Theoretically, they lihaयचं P max is equals to 30 square, 30 square divided by 11 into 4.